Hi everyone, today I wanted to share with you this cool little experiment on how to find the spring constant of some rubber bands. So all you'll need are the objects on the right, so the tape, a ruler, a scale, a pencil, and some rubber bands. Now you will also need a couple objects that will allow you to hang other weighted objects from a rubber band. So I'm using a carabiner and a bucket, and I'll be just hanging various objects like coins, but it doesn't really matter as long as you can hang something from the rubber band. Okay, so once you've got your materials, the general idea of this experiment is the spring constant is that K you see in the middle there. And basically, in the beginning, when there's no weight attached to the rubber band, the rubber band doesn't need to apply an upwards force to really cause it to remain in equilibrium. But as you add weight to the bottom of the rubber band, those objects have some gravity force on them acting down. So the rubber band needs to apply a force upwards to keep the object stationary. So to find the spring constant, we'll compare the force of gravity of these different objects, which will be equal to the force of the band, with the amount that the rubber band stretches, which is that X you see. Alright, time to set up the experiment. So first we're going to get some piece of tape and your pencil, and you're going to tape the pencil to some table or desk or whatever, some surface above the ground. And it doesn't really matter, just make sure it's secure. Next you're going to get your rubber band, and you're going to hang it from the pencil, as so. Now what I'm doing is I'm now measuring the length of the rubber band before it's been stretched. I'm trying not to stretch it too much, but it looks to be about 7.5 centimeters or so. With your rubber band, make note of where that is, of how long your rubber band is without the stretching. There we go, double checked it. There it is. So now we're going to hang the carabiner from the rubber band, and then we're going to hang the bucket from the carabiner. And now we're going to be able to put different weighted objects in the bucket. We're going to take the carabiner and the bucket off to weigh it, but we'll be putting it back right after that. So yeah, let's weigh it. As you can see, the bucket weighs 64 grams, and when you add the carabiner, it comes out to 83 grams. And whatever you're weighing, just make sure to weigh it and see how much it weighs. Alright, so now we're going to add back the carabiner and the bucket. And we're going to start adding the items that have already been weighed. So basically, now we're going to measure how much the rubber band was stretched with the weight of the carabiner and the bucket. And now we're going to add the weight. So after each application of adding weight, you're going to remeasure how far the rubber band was stretched from its original distance, original length. And you're going to keep doing this until the rubber band is, pretty stretched. But you don't need more than maybe 5 iterations. Alright, so you've collected your data. Now it's time to put it onto a graphing calculator. So you can see my x-axis on this table is the displacement or stretch length from the original length of the rubber band. My y-axis is the force that the rubber band has to exert upwards to counteract the force of gravity downwards. And they're going to be equal in magnitude, which is why I multiplied the masses I added by 9.8, because that is G. So 9.8 newtons per kilogram times whatever the added weight was, is going to be equal to the force that the gravity exerts. So then I add a line of best fit, which is that red line you see, and it shows you K, and K is our spring constant. So as you can see, it takes 117.4 newtons to move the rubber band 1 meter, although obviously it would break before then. Anyway, thank you for listening, and I hope you enjoyed. Bye.